Hello, everyone. This is Kenneth Wong, Senior Editor for DE 24/7, reporting from Synopsys Converge Conference in Santa Clara, California. This is a conference that combines several different events into one: an executive forum, the SNUG, or Synopsys User Group Silicon Valley's gathering, and what used to be ANSYS Simulation World. The crowd was estimated to be about 2,700, according to Synopsys. This also marks the first release of ANSYS products after Synopsys acquired the company. So I'm going to be speaking to some Synopsys executives to get more insights into their post-merger integration strategy.
Well, with R1, every time we release it, we always advance our numerical physics. So, although that's sort of an essential element that we build every time, we are always trying to solve more challenging problems more effectively. But what we're saying now, because of this new release with the broader Synopsys, is that we are saying, physics first, physics forward, plus being system aware. So merging together the idea of multi-physics together with EDA. Now, I like what I've heard Sassine say many times. He talks about the idea of one of the most urgent needs is in advanced packaging, 3D IC and other advanced packaging issues, where we've run into a new challenge, right? If we're going to meet the needs for advanced semiconductor design, we are necessarily going to have to look at the multi-physics elements of it. Electromagnetics comes along when we want to send high-speed signals. Structural analysis, if we want to look at, say, drop test or thermal analysis where we have things that expand and contract. Even fluid dynamics for making certain that we can handle those types of, say, advanced cooling that might be found in semiconductors. That's the biggest challenge. We've done a lot in that capacity with R1, but that's just the beginning of it. There's really several other areas which we're pretty excited about.
But if you look at, for example, crash testing, it's very expensive to do it with real cars, even with real prototypes of a car. So what ANSYS has been able to do is to kind of say, how do we enable this with a digital twin, do this virtually, do that in a way that is very realistic and can be used to make the car safer. Nowadays, if you look at cars, planes, a lot of other industries around us, the electronics and the software has become such a big content of those devices. So naturally we're thinking about, okay, how do we leverage Synopsys presence on the electronic side with the learnings that we have from digital twins on the physics side and implement electronics digital twins. And this is something that Synopsys cannot do by itself. So for us it was important to put the ecosystem together and to create a platform that is open for different tools, for different pieces to come in to represent all the electronics in a specific system, for example in a car, and then make sure that the users can look at the software content across the system. For example, in case of automotive, you can think about an ADAS system interacting with the braking system, with the infotainment system, and you're testing the software components across all of those rather than just looking at it from a component point of view.
You always consider yourself with a digital twin the idea of a very valuable deployed asset. Think of a jet engine on a commercial aircraft. Well, we want to design that product such that it is very effective and reliable, but we also want to manage it by looking at its performance while it's deployed. And we have new technologies that merge those things together to be able to look at a hybrid digital twin to have the best of both worlds. That is, in design, where you're designing I made a mention of a jet engine, but also that's under the control of embedded intelligence. So there are semiconductors involved. There's a software stack built into that premise, and then on top of that we are more and more utilizing artificial intelligence to be utilized in that design, and so that's another area. And then there's exciting areas where we're merging together some of the products. Photonics comes to mind. Looking at the idea of embedded in photonics in semiconductors, for example, where we've already have integration with the traditional Synopsys area and the and that which was an ANSYS development, or simulation and analysis, as we call it. And that is what we're doing there is we have there are Synopsys tools, the opto compiler, and there are the numerical tools, which is from the multiphysics space, where we do we want to extract from first principles the behavior of optical components that might be in a optical device, and so we use the physics to solve for the behavior of those components, and then bring that into the optocompiler tool suite to be able to look at overall performance. What's exciting about that is that the Synopsys tools in that space can go all the way to RTL coding to produce a design and then run simulations. Sort of if you will, by looking at RTL, you're looking at the representation of the semi itself.
One of the familiar faces in the Silicon Valley is NVIDIA CEO Jensen Huang. At this conference, he made a cameo appearance during the keynote discussing the role of GPU-powered NVIDIA Omniverse platform for digital twins.
If you look at kind of the digital twin of what we now call physical AI, you kind of have three important components. You have the digital twin of the physics, you have digital twin of the electronics, but given that it's physical AI, it interacts with its environment, it's also important to have a digital twin of that environment. And so that's where tools like Omniverse come into play. What you want to do is you want to say, okay, for example, I have sensors. So with ANSYS AV Accelerate, you can do modeling of the sensors, but you need to test how those sensors interact with the environment. And that's where Omniverse comes into play, and where we did a tight integration between our AV Accelerate product and NVIDIA's Omniverse.
That's all from Synopsys Converge Conference. Until next time, I'm Kenneth Wong for DE 24/7.